Okay, this better be working or I quit. 2007, what a year. 2007, question number 6 from the BC exam. Here we go. Hopefully I have enough room. Let f be the function given by f of x equals e to the negative x squared. Write the first 4 non-zero terms and the general term for Taylor series about x equals 0. So when I did this one already, when I started writing out the Taylor series for this and doing it as a Taylor series, the work became a lot because this derivative became a lot. So I would say if you first start and I have f equals e to the negative x squared, I'm going to have to find the first derivative, and I see, okay, the first derivative is e to the negative x squared times negative 2x. Now I have a product rule for the second one. This is going to take me a while because I want the first 4 non-zero terms, but I'm centering at 0. So look what happens when I plug 0 in. When I plug 0 into the first term, I do get 1. 0 into this one gives me 0. So this isn't even going to be able to count in terms of finding the first 4 non-zero terms. So I want to use substitution instead. So just because they say Taylor series does not mean I have to use the Taylor series setup. I can use any setup I want. The result that I get from using the Taylor series setup is the same thing I would get if I use substitution. Using a Taylor series is more like a last resort if I can't substitute or if the series is not geometric. So if I can substitute, I'm going to do that. I definitely have not made that clear, but hopefully now I am. So part A, well, let's remember what we know. We know the series for e to the x. We know e to the x is 1 plus x. It's all pluses. There's no factorials. Okay, we know that's the series for e to the x. So let's take, oh wait, there are factorials. Never mind. Sorry, I was thinking of something else. Sorry, there are factorials. But let's take that and substitute. So the series for e to the negative x squared will be 1 minus x squared. I'm subbing in negative x squared for all of my x's. Plus, because when I put in negative x squared into this will become negative x squared squared. So it'll turn this into plus x to the 4th over 2 factorial. Plug negative x squared into this, and now I will have to the 3rd, so I will have minus x to the 6th over 3 factorial. And there we go. Write the first 4 non-zero terms. There they are. So there's part A. Oh, shoot. And the general term. Forgot about that. So this can be written as the series. We're going to have an alternator. X is going to be raised to all the even powers. But on the bottom, we're still just going to have n factorial. So let's see how this shakes out. If I start at 0, that's a good place to start because plugging in 0 for here will give me a 1. 0 down here gives me a 1. And then this can also just be n so that the first term turns out positive. Let's double check. What happens when n is 1? Now we have a negative. This is going to be x to the 2nd, and this is going to be 1 factorial. So good. I just saw something just yesterday about the scoring rubrics for series. And I saw somebody write on one of these calculus teacher forums that you have to write plus ... and another plus ... I don't even know why I'm saying this. I guess you only have to do that if we don't put the summation notation. So yeah, never mind. Ignore what I just said. I think what we have is just fine. Oops, erase that. And I'm going to say this equals that. Okay, so there we go. First 4 non-zero terms and the general term for that series. Part A, done. Part B, use your answer to part A to find this limit. Well, we haven't done limits in a really long time, but that's okay. So I'm going to run out of room, I think. Let me see. No, I'm okay. To do part B here. So first I need to find this series, 1 minus x squared minus my series over x to the fourth. So that is 1 minus x squared minus my series all over x to the fourth is what they're asking me to find. And my series is this. So what happens when I do that? If I put this series in here, so 1 minus x squared plus x to the fourth over 2 factorial minus x to the sixth over 3 factorial. Sometimes I like to get myself an extra term just so I see how it's going to look. So this would be a plus x to the 8th over 4 factorial. I'm just following the pattern. Dot, dot, dot. So how does this all cancel out? Well, the 1 minus the 1 will cancel. Negative x squared minus negative x squared will cancel. And then all of these will have to get divided by an x to the fourth. So what I'm going to have left, this negative is going to have to distribute to everything. So I'm going to have a negative 1 over 2 factorial, because this x to the fourth will cancel out, minus this will become a plus x squared over 3 factorial, because this x to the sixth will reduce with the x to the fourth. Oh gosh. My watch just brought up something about Maclaurin series. This negative will distribute, so this will become a minus. The x to the 8th will reduce, this will become an x to the 4th over 4 factorial. Okay, so this is my new series that I'm writing to represent the thing they want me to take the limit of. Well, they want me to take the limit of this as x goes to 0. Whoops. So what is the limit as x approaches 0 of this series? Well, as x approaches 0, every term is going to cancel. I'm going to plug 0 in for every x. So every term is going to become 0 except for this first term that has no x's in it. So my limit is going to be negative 1/2. Wow, that's serious. I'm just double checking my signs. Good. Okay. Okay, so there's the limit question. Oh, by the way, the answers to this, if you were looking at points, for the first one, you would have gotten 2 points for this series and 1 point for the general term. Remember, we're always trying to get, there's always a total of 9. We're trying to get about at 5 or more. They would have split this up to the first 2 terms being a point, the second 2 terms being a point. This part B is only worth 1 point. That's very little for that whole concept, but okay. Because we want to save it for part C. Okay, for part C, write the first 4 non-zero terms of the Taylor series for the integral of e to the negative t squared from 0 to x. Don't get freaked out about the different variables. They just don't want everything to be x's because that's a little weird. So let me get rid of some of this. I might need to rewrite. I don't want to get rid of my series for e to the negative x squared, so I'm going to rewrite that just so I have it. Make this neater. So from part A, I have the series for e to the negative x squared. I'm just rewriting it. 1 minus x squared plus x to the 4th over 2 factorial. So now they want us to find the integral of this. Okay, well, I can integrate both sides so that the integral of e to the negative x squared is equal to, let's integrate each term. The integral of 1 is x. The integral of this is x to the 3rd over 3. The integral of this is x to the 5th over 5 times 2 factorial. X to the 7th over 7 times 3 factorial. They want the first 4 non-zero terms of the series, 1, 2, 3, 4. There they are, the first 4 non-zero terms. Okay. That gets us, by the way, 2 points. So 2 points just for that. And use the first 2 terms of your answer, so just these, to estimate the integral from 0 to 1/2. So now they want us to find the integral from 0 to 1/2 of e to the negative x squared, saying that the integral of this is going to be found by taking just the first 2 terms of that series. So this, and evaluating from 0 to 1/2, just like we do with definite integrals. Plug in 1/2, so we're going to have 1/2 minus 1/2 to the third, so 1/8, minus whatever we get when we plug in 0, which is going to be 0. So we're going to have 1/2 minus 1/24. This will be 1/2 minus 1/24. This will become negative 24, 12, 11 24ths. Not negative, sorry, 11 24ths. Boom. 1 point for that. Okay. 2 points left, and they all have to do with error. So explain, this is actually going to be the easier form of error, not the more complicated form of error. But you might not know that yet. So explain why the estimate found in part C differs from the actual value by less than 1/200th. When we see that kind of wording, explain why something differs from the actual. This is asking me to find error. But they don't say Lagrange error bound, so I'm not having to use that Lagrange error bound formula. I just need to find the next term, which I understand Lagrange error bound really is the next term anyway, but this is going to be even easier. So explain why the estimate found in part C. All right, well, the estimate found in part C used only the first 2 terms. So they used a 3rd degree Taylor polynomial, which happened to be the first 2 terms because the squared one was 0. So to find the error, I am just using the next term, which is right here. So to find the error, I don't have to do a whole lot of complicated stuff. I just need to use the next term in the series. So I'm going to evaluate this term at what? Oh, at 1/2. Got it. Okay. So this was that last number, sorry, the 11/24 was the approximation for the function at 1/2, basically, even though it was still the integral, it was still from 0 to 1/2. So now I'm going to be finding this at 1/2. Plug 1/2 into this, I'm going to have 1/32 over 5 times 2 factorial. That's going to become 1/320. Show that this error, this amount, is less than 1/200th. Yup, it is. Check. That's crazy, right? The error thing is nuts. So it looks like you have 2 points for that. And yeah, they say to explain, so explain why. You could say this series is an alternating series. So its error can be found by finding the value of the last term. not the last, of the next term. Okay, we'll try another one.